Hello, ladies and gentlemen. Today's topic is properties of numbers, and our objective today is I can recognize the different properties of numbers. Those are things like the associative property, the distributive property, the multiplicative inverse property. There are lots and lots of them. And it's one of those things in math that when you're 35, are you really going to need what the commutative property means? And my best answer to you is no. You really aren't going to use the commutative property in most of your careers down the road. However, in your future classes, your future math classes, teachers are going to expect that you already know it. So I would be doing a disservice to you if I did not try and have you guys memorize these properties. And there's a couple that really do come up all the time. One of them is distributive property, and we are going to be using that constantly this year. So on the next blank page in your notebook, you're going to put the heading, properties of numbers, the objective, I can recognize the different properties of numbers, and then I want you to put a line right under your objective and split the rest of your page in half. Okay, so if this is my page in my notebook, I've got a line under my objective and I've split the rest of my page. The first one we're going to talk about is the additive identity property. And you're going to write over here on the left-hand side of your first little section, or I guess suppose it's your second little section. On the side, just write additive identity. I would even write it going sideways. I'm not even going to try and write sideways using my computer mouse. That would be silly. So I'm going to do it this way. Additive identity, and just put that right over there. Okay? So the additive identity property. I'm going to show you each of these properties in words, in symbols, and then I'm going to give you an example of that. This is a homework assignment with a lot of writing. I am sorry. The video itself is going to be hopefully short, but you're going to have to pause it and write a lot. So the additive identity in words is for any number a, the sum means addition, don't forget, of a and 0 is a. So a plus 0 equals 0 plus a. That's actually using the commutative property right there, which we're going to see. And that just equals a. An example with real numbers is 2 plus 0 is 2. 0 plus 2 is 2. So anytime you add 0 to a number, it equals that number. Okay, but you need to be able to understand that and remember that it's called the additive identity. It's not so much understanding the properties that's the hard part, it's memorizing all the names, okay? All right, pause if you need to finish writing that, and if not, we're going to go on. The additive inverse property. Go ahead and write this one over here in this section, the last section on that page, additive inverse. And in words, a number A and its opposite are additive inverses of each other. And we've been talking about this property a lot in class when we're doing integers. And I think that it was most of your favorite method for adding and subtracting integers. That's when we had -6 plus 4. We split -6 up into -4 because that is the additive inverse of 4. And then -2, which is left over. And then the additive inverses cancel each other out and equal 0. So in symbols, a plus -a is going to equal 0. And an example with real numbers is 3 plus -3 equals 0. And this one I love, this 4 minus 4. I love it because what have I told you to do with subtraction? I want you to turn it into addition. So keep the first number, change it to addition, take the opposite of the second number, and you will see that now I have my additive inverses. A lot of people can get confused in an example like this. Moving right along, let's go ahead and talk about properties of multiplication. Put this on your next blank page, and you're going to divide this page into 3 sections because there are 3 properties of multiplication that we need to talk about. The first one is the multiplicative inverse. No, I'm sorry, the multiplicative identity. You might remember from just a couple slides ago when we talked about the additive identity that it was any number plus 0 is going to equal that same number. Identity is a key word here, okay? It's almost like We don't change the identity of 2. We keep it exactly like it is when we add 0 to it. So let's keep that in mind when we look at this multiplicative identity property. So in words, for any number, the product of a and 1 is just going to be a. In symbols, that's a times 1 equals a, or 1 times a equals a. That dot, just in case you forgot, means multiplication. And our example is 14 times 1 equals 14, and vice versa. Once again, we talked about how identity means that the number stays the same. In multiplication, in order for your number to stay the same, it has to be multiplied by 1. So that's your multiplicative identity. Take a minute to write that down, and then we're going to move on. Multiplicative property of 0. See, all of these properties, guys, they're things you already know. You just don't know the word that goes with it. So in words, the multiplicative property of 0 is that pretty much when you multiply a times 0, you're going to get 0. That's what it looks like in symbols, and an example is right here. You know this stuff, but you have to memorize what it means, okay? Like I said, it's a lot of writing today, guys, I know. Just keep up, pause if you need to, and bear with me. There's not many days that are this much writing. Okay, the multiplicative inverse property. All right, inverse. When we looked at additive inverses, we looked for numbers that add together to equal 0. When we're doing our multiplicative inverse, we're looking for numbers that multiply to equal 1. And this definition cracks me up. It's very math speak, okay? And it's going to make a lot more sense when you see the symbols and the examples, but I want you to write this definition down anyway. For every number a over b, hang on, there is exactly one number, b over a, such that a over b times b over a equals 1. Whew, math speak can be very confusing, I know. In symbols, it's as simple as this. A over b times b over a equals 1. Now I know you remember that we learned how to cancel fractions, right? Take a look at this fraction, 4/5 times 5/4. My 5 and my 5 can both be divided by 5 to give me 1. My 4 and my 4 can both be divided by 4 to give me 1. So then I just have 1 over 1, which equals 0. So how do you find a multiplicative inverse? You take whatever number you have and you flip it. So even if I have a whole number like 3, the multiplicative inverse of 3, well, I can turn this into a fraction by putting it over 1, and then flipping it is 1 over 3. That's how you find multiplicative inverses. Sorry, that should be a dot, not a minus. Okay, moving on. Other properties that are important, and this is where we get into associative, commutative, and distributive properties. Lots of words still, I know, I'm sorry. So, properties of numbers. Put on the next blank page of your notebook the heading, and then this time divide it into 3 sections. The first section is the commutative property. So in words, the order in which you add or multiply numbers does not change their sum or product. In symbols, a plus b equals b plus a. I can switch the order of my letters, and it's still perfectly fine. I can do it with multiplication also. This is a property that works for addition and multiplication. And this is what it looks like with real numbers. The way I always remember commutative property, there's 2 little tricks you can use. One is to notice commute. Okay, have you ever heard somebody say, I commute to work, or my commute to work is 35 minutes long, or I'm a commuter if they're a college student? A commuter is somebody who drives from one place to another to get to, say, school or work. Okay, so they move from one place to another. The letters move their position. Another way to think of it is the first 2 letters of commutative are CO. And you can use that to remind yourself that you change the order of the numbers. So the C goes with the change, and O goes with order. So in commutative property, we change the order of the numbers, and it still equals the same thing. It only works with addition and multiplication. Do not try and use commutative property with subtraction. In order to use the commutative property with a subtraction problem, you would need to change it to addition. So if I have 3 minus 10, I cannot just do 10 minus 3 and get the same answer. I have to change it into an addition problem, and then I can change the order and do negative 10 plus 3. Okay, that's very important. It's a mistake a lot of people make. All right, let's go ahead and move on to the associative property. The associative property says that the way in which you group 3 or more numbers when adding or multiplying does not change their sum or product. So it's all about grouping, the associative property. And I like to remember this with associate. The people you associate with are your friends, they're your buddies, okay? In symbols, if we look at this, over on this side of the expression, A and B are buddies. They're hanging out together in the parentheses. Over on this side, B and C are buddies. So the associative property means that you change what numbers are associating with what. So A and B are associating, but now B and C are associating. And if it's all addition, that's okay. That will not change the value of your answer. If there is subtraction thrown in there, it will. So you have to change subtraction to addition. An example, 3 plus 5 plus 7 is going to equal the same thing as 3 plus 5 plus 7. All you do is change where the parentheses are. Okay, it's all about the parenthesis symbols for the associative property. Last, and probably the absolute most important, distributive property. The distributive property lets you multiply a sum, that's an addition problem, by multiplying each part of the sum separately and then adding the products. What is that? Math speak is crazy. But if I have a situation here where I have A parentheses B plus C, first thing we have to realize is that that parentheses really means that A is being multiplied by B. Okay, and don't forget, a little dot is the same as multiplication. So we're trying to do A times this quantity B plus C. Well, I can do it, I can kind of split it up. I can first do A times B, that's shown right here, and then I can do A times C, which is right here, and it's going to give me the same answer. I add those together, and it's going to equal the same thing as if I had done B plus C first and then multiplied it. Let's look at it with some numbers that might make more sense. Okay, so if I have 6 parenthesis 2 plus 1, remember that that parenthesis means that 6 is multiplying. Mathematicians are occasionally lazy and don't like to put all the symbols in. So if I look on the left side of my equal sign, I'm going to do it following this order of operations. I'm going to do 2 plus 1 first, which equals 3. And then I'm going to say, okay, 6 times 3 is 18. But the distributive property says that I can actually take this 6, multiply it by 2, that's this right here. Take the 6, multiply it by 1, right there. And then 6 times 2 is 12, 6 times 1 is 6, and I end up with my same answer. Okay? As long as you distribute or give this 6 to the 2 and the 1, you're going to get the same answer. We're going to do a lot of practice with these properties in class tomorrow, guys. You will get the hang of it, I promise. Just bear with me, see what you can remember from this lesson, and for your reflection, I want you to tell me which property is most confusing to you and why it's so confusing. Okay, make sure you respond to that in Edmodo. Thanks, guys. Have a good night.